Hello students, today we will be learning about integration by parts. Until now, you have learned only how to do basic integration with one function, for example the integral of x or the integral of cosine x. But what if you had the integral of x times cosine x? What would you do then? This is where integration by parts comes in. The formula used for integration by parts is uv minus the integral of v du. And we'll explain the nature of this formula in a few moments. In order to get the function to look like this, you will have to find four variables: u, du, dv, and v. When first doing this, you must separate the two functions into either the variable u or dv. In the equation above, let's make x equal to u and cosine x equal to dv. The reason we want to do this is because the derivative of u, in this case, will yield 1, and the integral of dv will yield sine x because the integral of cosine x is sine x. Now, since we know all the variables, let us plug this into the formula. We know x is u and v is the sine of x, then minus the integral of sine of x, since v is 1 dx because that is the value of du. It is now possible for us to integrate the value of sine dx, giving us negative cosine x. A negative and a negative become a positive, resulting in x sine of x plus cosine of x with a plus c, because there could be any constant to the indefinite integral we integrated. And now let's try this with another example.
Let's try integrating x times e to the x dx. Let us write our variables u, du, dv, and v. Let's set u equal to x and dv equal to e to the x. That way, du is 1 dx and the integral of dv is e to the x, because the integral of e to the x dx is e to the x. Then let's plug these values into the formula, giving us x times e to the x minus the integral of e to the x times 1 dx. Since we know the integral of e to the x is e to the x, the ending result is x times e to the x minus e to the x plus c. Since we've covered the basics, let's try something harder. Sometimes, when doing integration by parts, you might have to integrate multiple times. Let's try integrating sine of x times e to the x. Let's find u, du, dv, and v. Let's set u equal to sine x and dv equal to e to the x dx. Now we can find du, which is cosine x dx, and v, which is e to the x. Let's plug these back into the formula. We get sine x times e to the x minus the integral of e to the x times cosine x dx. Because we can't leave the integral like this, let us integrate it by parts again. Now let's find u, du, dv, and v again for this new integral. Let's make u equal to cosine x and e to the x dx dv. Based on this, we can find that du is negative sine x dx and v is e to the x. Let us plug this into the formula at this point in the equation, and we get, in the brackets, cosine x times e to the x minus the integral of negative sine x times e to the x dx. Now, we can take out the negative in this integral, and we can make this integral positive. Now, you might notice the integral here is essentially the same integral we started with. If this is the case, distribute the bracket into the rest of the equation and set it equal to the original integral. Then, in this case, add the same integrals to get sine x times e to the x minus cosine x times e to the x equals 2 times the integral of sine x times e to the x dx. Divide 2 to both sides and add c to the quotient, giving you your answer.
Thank you for watching this video. We hope this helped you understand how to do something as complex as integration by parts with ease. We demonstrated 3 examples that we thought were best for understanding this hard topic. Thanks for watching. Join us next time where we will talk about more methods on integration.